All right, let's start. I know we had a good number of people out on Thursday before break. Highly recommend you watch that video from the class you made. We went over a ton of questions as a class, a ton of review questions, and also the review right now, which I'm not going to go over as slow as I did and detailed as I did on Thursday before break. So you guys that weren't here, I highly recommend you hop on that video and watch it before tomorrow. So here we go. Tomorrow, nothing's changing. We're still having this test tomorrow. You guys have known this for a while. I'm still going to go over questions today. I'll maybe leave you a little bit of time for you guys to do stuff on your own, but honestly, I don't trust you guys to prepare as well as you need to on your own today in class. So that's why we're going over question by question. And also, after we're done with the question, I might say, all right, if this is a rhombus question, let's review all the properties of a rhombus. If I ask you to prove a rhombus, because you guys see we have one coordinate proof tomorrow. If I ask it to be prove a rhombus, how you doing it? So I want to go over every single scenario before you guys leave, because I am not joking around tomorrow. You got to know all your properties. Kite, trapezoid, isosceles trapezoid, the parallelogram family. You're going to have a question on every single figure tomorrow. I can guarantee that. All right? Anything you want to ask before we start? Because I'm going to do the same thing as I did on Thursday before break. Let's find a number, let's do it, and let's go. I also want to just remind you guys, if you have forgotten already, that there is an extra review in addition to the 28 questions you have in the back of your packet. You have an additional review up on Classroom. Okay? Extra practice for the unit test. Also want to remind you guys, you don't have this in your packet. It's up on Classroom. If you guys want a chart of all the properties, so you could start quizzing yourself, it's right up here up on Classroom. So it goes through figure by figure and lists all the properties for it. All right? Good questions? All right, let's jump right into it. All right, no joking around here today about, how everyone was breaks was. Great. We'll worry about it after. Where's my numbers? Right here. We already did 28 as far as the homework goes that one night. So 19, and let me know if we did it or not, because I don't want to waste time. And I mean, we did it as a class, not because you did it individually over break. Because I know we went over a ton that Thursday before. We did. I remember doing this one. Yep. So we went over 21 already. And again, if you weren't here, we did it up on the video. Take a look. All right. How about 5? I feel like we did that as well in the homework. 5's blank. Okay. Here we go. Number 5, everyone. We're going to go over a bunch of rhombus properties here in a second. Number 5. Paste. You guys can get it set up right now if you'd like. Come on. Remember, as we label a quadrilateral, please label it clockwise or counterclockwise. All right, don't jump diagonally. Label every quadrilateral clockwise or counterclockwise. ST 4y minus 9, and then I have TA as 2y plus 5. All right, what's a property of a rhombus that I'm going to need to know here? Well, what's the relationship between TS and TA? Oh boy. They're congruent to each other. All sides in a rhombus are congruent. So that allows me to say 4y minus 9 equals 2y plus 5. I don't know that unless I know all sides in a rhombus are equal. Know your properties. 2y equals 14. Y equals 7. Now I got to find the perimeter. That's all 4 sides added up. But since you guys just told me, since I know one side, I know all of them. So I say, all right, I can pick a side, doesn't matter. TA. 2, plug in your 7. plus 5. TA is a length of 19, meaning all four sides are 19. So the perimeter, it'll just be 19 times 4, 76. Let's stay here. Other properties of a rhombus. Okay, all four sides are equal. Let's go. Tell me something about the diagonals. Not equal in a rhombus. Not equal in a rhombus. Scott, perpendicular. That's huge. Now what type of triangles do I have in the middle here? Right triangles. And if you have right triangles, you could possibly use this bad boy, known as the Pythagorean Theorem, which you're going to need. Only in a rhombus, though. Diagonals are perpendicular. Now you have a right triangle. More. Diagonals are perpendicular. Romeo. So that means these two are equal. These two are equal. They bisect the angles. And what else about the diagonals? Perpendicular, bisect the angles, and remember, it's a parallelogram. Bisect each other. All right? They bisect each other. Good. Next scenario before we move on. Let's say I ask you to graph quadrilateral star up here. Prove it's a rhombus. What formulas are you going to need? Prove it's a rhombus. It's on your graph. You graphed it tomorrow, and now I'm asking you to prove it's a rhombus. Distance formula, correct. Distance, and I'm not giving that to you. Distance, midpoint, slope, not giving it to you. So I'm going to need 4 distances. Questions here? All right. And that was just the first one we're doing here today. And it's already picked up in intensity. 25. Let's take a look at 25. I believe that's a proof. Have we done it? Nope. Perfect. Statements and reasons. Prove this is a parallelogram. One and 2 are equal. 3 and 4 are equal. All right, if I'm going to show it's a parallelogram, got to see one of the properties has to exist. Opposite sides congruent, opposite sides parallel. One pair parallel and congruent, special case there. Got to show one of those exists. So let's first start with 1 being congruent to 2. What conclusion can you make if 1 and 2 are equal? Zach?
PQ and SR are the 2 lines I'm pretty new in parallel.
Okay, if 1 and 2 are equal, that means PQ and SR are parallel. I also have 3 and 4 though. I don't want to make a new statement up because this is going to be the same reason. Now that I have 3 and 4, that also tells me PS and QR are also parallel. Ooh, what was that reason? Nope, you're missing something. Because look, right, if I write alternate interior angles and that's it, they need to be congruent. Remember, they need to be congruent for you to have parallel lines. Is this enough or do I need more to show it's a parallelogram? Opposite sides parallel. Good enough or do I need more? Oh, I don't know. Maybe I'm studying tonight. I don't know if I need more. Let me go back to my cheat sheet up on Classroom. That shows me all the different ways to prove a parallelogram. One side parallel, other side parallel. That's good enough for a parallelogram. I don't need any other info. Don't need anything else. So PQRS is a parallelogram. And what are we going to write down for the reason if I come upon this tomorrow? Well, what did you just prove? Look at your darn proof. Opposite sides parallel implies a, there we go. Questions there? All right, let's keep trucking. 16. Did we? Okay. 14. Okay, doing that one. Okay, we notice it's a parallelogram, so all my parallelogram properties apply. DCA, this angle right here is 40 degrees. ADE is 70. Okay, how are we getting to ABC now? And I put a right angle symbol in there as well. How are we going to get to angle ABC? It is a parallelogram, remember? All right, so if that's a right angle, right next to it's got to be a right angle. Got it? Okay, anybody want to fill in any missing angles here to get to ABC? We're not going to find ABC right away, but you should be able to fulfill in some unmarked angles. Scott, go. CDE is 50, 180 degrees in a triangle. So I know that angle's 50. All right, I'm working my way here. Emma?
Wouldn't CAB be 40 degrees?
Okay, I could also put, if angle DCA is 40, the alternate interior angle CAB is 40. Yep, we're getting there. Remember, I got to get to ABC, and this is a parallelogram. I think we have enough info right now to find it. Finding ABC. What do you know about opposite angles of a parallelogram? They're congruent. So what's ADC? 70 and 50? 120. So the opposite angle, ABC, also has to be buck 20. I'm sure you could find more angles to get there, but knowing opposite angles are congruent. Done. Woo-hoo, moving on. 2. Parallelogram, which statement must be true? All right, this is just straight up, do you know the properties or not? This is it right here. Which one is true? True. All right, diagonals, are they perpendicular? AC and BD, those would be diagonal. So are they perpendicular in a parallelogram? Nope, but hey, let's go. Name the figures. That would be. Let's go. Name the figures. Rhombus. Square. Are the diagonals congruent in a parallelogram? Congruent? Nope. Name them. What figure would I be in if the diagonals are congruent? Okay, rectangle. Square. I'm still waiting. This is what I'm talking about. Got to know everything coming in tomorrow. Isosceles, trapezoid. And I even forgot one up on perpendicular. That's my fault.
No, just normal. Just wait.
Diagonals perpendicular and a kite. Perpendicular and a kite. Does diagonal AC bisect the angles it's drawn to in a parallelogram? Parallelogram? Nope. What figures am I talking about? Rhombus and square. Hopefully this has opened up some eyeballs here. Ooh, baby, a lot of properties. So the answer is that yes, the diagonals bisect each other. Hey, whoa, no, you think I'm done here? Let's go. What else? Where else do they bisect each other? Yep, parallelogram, great. Rhombus, rectangle, square. Do they bisect each other in an isosceles trapezoid? No, they're just congruent. In a kite, they do not bisect each other. The longer bisects the shorter. Remember, in a kite, they do not bisect each other. Longer bisects the shorter. Questions there? Sure. All right, I'm going to go over one more with you, and then I want to make sure we take a look at one figure in particular. All right, so let's do one more. How's 3 looking? Right next door. All right. Perpendicular, everyone. Putting the right. Where are we putting the right angle here? Name the angle. DCE is a right angle. And B and E are congruent. All right, somebody get me to angle CDE. It's a parallelogram, and I already have the 100 in angle A. So there's a couple other angles you should be able to mark. What's angle B then? Parallelogram property. Consecutive angles are supplementary. That's 80. Meaning if angle B and E are congruent, E's got to be also 80. All right, so angle E is 80. Can you guys get to angle CDE now? All right. I take 180 minus 90 minus 80 and end up with 10 degrees. All good? All right. I would like to just touch on the isosceles trapezoid and the kite real quick before I let you go on your own. All right, let's talk isosceles trapezoid properties. I know one pair of opposite sides are parallel. What else do you know?
Is it A, B, and B, are not congruent?
Legs are congruent, correct. Legs are congruent. What other property should I know? Isosceles trapezoid. Legs are congruent, other pair parallel, yep. Diagonals. Congruent. Let's keep going. Base angles. What do I mean by base angles? B and C, along with A and D. Base angles are congruent, correct. All right, next question. And I'm sure we're not doing this just to waste time, right? It has to be something with the test. You graph this figure. Tomorrow, you graph it, and I ask you to prove it's a trapezoid. Prove it's a trapezoid. What's your move? Prove it's a First of all, what formula am I going to need here? Just a not isosceles. I just want to prove it's a trapezoid. To prove a trapezoid, I'm going to need distance. Just a trapezoid. Just a trapezoid tomorrow. I'm going to need slope, because what are you going to have to show me about BC and AD? That they are parallel. So you need to show me the slopes are equal. Plus what else? If you just do this, just show me one pair is parallel and that's it, that could still be a parallelogram. It's not necessarily a trapezoid. So in addition to showing me one pair is parallel, the other pair has to be not parallel. Okay? Not parallel. So if you want to prove a trapezoid, prove one pair of sides parallel, the other pair not parallel. Okay? The other pair not parallel. Got to prove the other pair not parallel. All right? Good? Just want to make sure in case that comes up tomorrow. Slope formula, that's on you. Rise over run, change in y over change in x, that's on you. And then the final thing, I just want to go over properties of a kite, especially if a kite question shows up tomorrow. I don't want to be get freaked out here. Actually, that's probably not the best. There we go. Okay, kite. I'll give you those are congruent. All right, what do I know about a kite? One pair of opposite angles are congruent. How do I figure out what pair? Look where the non-congruent sides meet. All right, look where the non-congruent sides meet. So one pair meets at A, the other pair meets at C. So look where the non-congruent sides meet. Those are the angles that are congruent. And that's it. Not the other pair, just those two. What else?
BD bisects AC.
Longer diagonal, BD, bisects shorter diagonal, AC. They don't bisect each other. They do not bisect each other. So let me draw that in here. That's it. That's it. And one other big one. Diagonals are perpendicular. Oh, so they form what? Right triangles. Maybe we might have to use what now? Pythag. Okay, right triangle might have to use Pythag. Questions here? Okay, I'm going to leave it up to you now. All right, we're not moving around, changing seats. If you want to work with people in your group, that's fine. You got the 28 questions in your packet. Answers are under homework answers, so you might want your Chromebooks out. Or if you choose, try the extra review right now if you want. All right, answers to the 28 questions in your packet are up under homework answers. All right, call me over if you have questions here. Zach. Okay, give me 1 second. All right. Aiden, I hope you're listening right now, just to fill you in for tomorrow and how you're going to take the test. Aiden, you need to sign in to the Google Meet like you are right now on a second device, preferably probably your phone. And you set that up off to the side so I can see your surroundings. On your Chromebook, you do not log on to the Google Meet. Instead, you log on to Formative, where I will have the test open for you to take. All right, so you'll be taking the test on your Chromebook tomorrow with a side camera logging into the Meet, showing me your surroundings. Also, Aiden, we have a new unit starting on Wednesday. So if you would like a hard copy of the packet, email me and I'll drop it off at the front of the school for you to pick it up. If not, you're just going to have to download the digital copy off of Classroom. All right, so that's the expectations for tomorrow. Log on, side camera, do the test on formative on your Chromebook with the stylus. Thank you. All right, Zach, let's take a peek here. I'll tell you what I'm missing and then see if you can produce it.